Yeah, I think it has started to record. So,
Hey
hey
everyone.
everyone,
Hey,
welcome
hi
to
everyone.
another welcome to another podcast centered around embedded systems. For the past several weeks, we have been getting messages separately on our LinkedIn accounts asking the relevance of data structures to the field of embedded system. So today we are going to explore that particular topic, which is how much data structures and algorithms are used in embedded systems. If they are used, what form, to what degree, should you focus on it, should you not focus on it, how much of effort should you dedicate to it, what happens if you don't know DSA as much. So we'll discuss all of those topics today. And yeah, I think without wasting much time now, we can dive in. Who wants to go first? And let's maybe talk about um, data structures that we have seen in embedded systems, in your experience. Who wants to go
So
first?
I want to
Yeah,
go
go ahead.
first. So as I see the non-OS RTOS or a free RTOS, which is very small,
Hmm.
I see only list as a data structure which is used more frequently. Okay,
I
and
see.
it is mainly the doubly linked list.
I see.
But if I go and see like Linux kernel, I see several other data structures as well, like
Hmm.
double linked list, uh, radix tree, and
I see.
bitmap array.
Okay.
Sorry,
I see. Okay. Um,
yeah.
hmm, okay.
So for an embedded system, if you know the double linked list, it is good to go. But
Hmm.
other data structures are seldom used in the embedded system.
Okay. Okay. Anybody else wants to take a stab at describing the data structures they have seen?
Okay, I guess majorly I have seen, as you said, majorly it's stack queue and linked list that majorly dominates the linked list, and the reason being more majority of if you go towards the more of microcontroller side, these are more of a memory constrained environments, and memory is a great resource for there, and that's why you want to stay with the linked lists, etc., which may not give you a better O of n kind of,
Hmm.
you know, but they are good for the memory. And also, like I feel one of the most misunderstood concept of DSA is asymptotic analysis,
Hmm. Okay.
where people don't realize that O of one is actually not constant.
Right. It's just
It is
bounded.
constant. It is a bound, and what
Right.
it means is it's a constant time. It doesn't mean
Right.
it's the fastest algorithm. That O of
Right.
one can mean anything. It can mean 150 millisecond. It can mean 1 second. And based on the input you provide, there's a good possibility that a O of n square algorithm can outrun O of one. And that's why
Right.
you
Right.
don't see hash maps as a very common data structure in embedded,
True.
because we are so hash maps were popularized by databases where you had humongous amount of data. They were
Hmm.
like a good data structure fit for that, but that's not true for most of the embedded systems where data that you process is very limited in a certain amount of time, and you don't have to manage terabytes of data. You are mostly
Right.
managing some megabytes of data at the time.
True.
So,
I
as
think
the
I.
relevance, yes, DSS have a relevant, and they are very niche areas. Like I know, at least in power, their trees are used in power management kind of places. And I have used topological sort in clock tree resolution.
Mm-hmm.
But it's relevant. But the most common used one are linked list. And is DSA everything? I don't think so. DSA forms only 5 to 10% of the programming. Even if there is an algorithm on data structure up there, it's like very small portion of the code. The rest of the code sits there to manage all those things going around.
I see. Okay. Anybody else wants to take a stab at describing the
I think,
DSS?
yeah, maybe I'll go next. What I feel is that DSA, personally, I feel uh, they are really novel in the sense it ignites creativity in people to find, a better approach than the preceding one. And now that with, the advancement in open source, you don't have to implement anything from scratch. Basically, you just
Hmm.
get the most available, the greatest implementation out there, which would have definitely, implemented those data structures. But when it comes to normal engineer who is working in embedded systems, I don't think we have to rely on that many data structures,
Hmm.
because we already get, it's like, we are already standing on the shoulders of giants here, who have done their research, who have done the most optimal data structure possible, given it as a library. You can just use that. So in normal day-to-day life, I would completely agree with, Rajat and Wasim here, or Kachra Seth and Munna Bhai, uh, that for my day-to-day work, I think I only relied on linked list. And basically, one of the best ways to sort of incorporate linked list, doubly linked list, is the container of API in Linux. So I think I would want to point, the viewers, go check out that API. It's a very,
Container
very
of.
container of. Yeah.
Could you
I think we can
describe it?
provide, yeah, we can provide the link in the description as well. So
Sure.
what they have done is they have, so as what we want to do is we want to keep list of anything, right, within our disposal in the memory. So for example, it could be list of processes, it could be list of uh,
Resources.
unattended timers,
Sure.
resources, everything. Now, previously in our college, what we would have done is we would have, the data structures associated with the list. For example, what all needs to describe a process
Hmm.
ID,
Hmm.
then, the memory map, registers,
The
process
page
control block,
table.
essentially
Yeah.
page
Yeah.
tables, right?
Yeah.
And because we want to integrate that in list, we would have, like, the previous pointer, the next pointer, and stuff like that.
Right.
Now
Okay.
all of
Hmm.
that would
Hmm.
be in the uh, structure which is
Yes.
defining
Right.
that PCB block.
Right. Right.
Now, what Linux, I think it started off with Linux, if correct me if I'm wrong, where
Fair.
what they
Yeah.
sought was, hey, the previous and next pointer and some other metadata which is needed just to maintain the linked list, doubly linked list thing, can be separated out.
Hmm.
It can be, it's same framework can be used for process linked list, then timers, then resources, and all other stuff. Why not
Hmm.
I provide the interface in a way where people can basically use that block to create any number of linked list with the
Hmm.
APIs which I provide. I think
Right.
I'm not doing a good justice to, what
I'll
it
kind
is.
of flash the
Hmm,
graphics associated with
hmm,
that. I think that would be the
hmm,
right
hmm.
thing to
Yeah,
do.
yeah.
Okay, so you were describing the container of. So how is the
Container
container
of
of relevant here?
it
I think I missed.
basically. So as a programmer, as a driver developer, right, or as a, I should say, consumer of the container of API, you
Mm-hmm.
don't have to worry about what offset my previous and next pointers fall to, right?
Mm-hmm. Mm-hmm.
Makes sense? Does it make sense? You can just, say, hey, I want to traverse the entire list. I will say, hey, list every. I forgot the actual name of the API, but
I see.
I can just traverse the list with that, the pointer to the main block instead of
Mhm.
the previous and next. I don't have to bother about that, basically.
I see. Okay. Okay.
And it
I
does
think
some,
this.
compiler offset magic
Mhm.
at compile time, where I mean, it's very beautiful. I mean, I'll provide a
Fair.
link in the
Okay.
description.
Sure.
Yeah.
Sure. I think
I think the
container of
Just
is
API
to
something.
yeah.
API is
So
list
just
and
to add to
contain.
Mohammed.
Okay.
So
Who wants to
we'll
go
get you.
next?
Okay. So I would just add to Mohammed's point, like the most common use case of we don't even have to go to any operating system. We use it in day-to-day life. Malloc. Whenever you do a malloc, what all the backend library is doing is traversing a linked list of
Yeah.
free memory,
Free spaces. But is it
free
a linked
spaces.
list or is it a
It's a linked
tree?
list.
It's a
It's a
linked
linked
list.
Uh,
list.
Okay.
I
I
think it
also know
depends
that.
on the implementation of the heap allocators, basically. So some can be,
Right.
as simple as linked list traversal. Basically, I think Rajat is
Yeah.
mentioning about the embedded version of
Fair,
the heap
Yeah.
fair.
allocators.
Mm.
But the
Yes.
more, I think, advanced ones would have like, multiple queues depending on, what block you are allocating. So they would have queue for 8 bytes, let's say. So if you are only allocating 4 bytes, it would make sense to allocate from the
8
8
byte.
byte long
Mm.
queue
Yeah.
instead of having to reserve entire
Yeah.
64K or 4K page.
What I do know is certain heap implementations also implement a tree
Yeah.
to track the free space and
Hmm.
also the allocated space. I
Hmm.
might be wrong on the allocated space part, but definitely to track the free
Yeah.
space, trees
Yeah.
are
I have
used.
seen one open source implementation of malloc, and there
Hmm.
they were using two double linked list, one for the allocated space
Hmm.
and
I
one
see.
for the available space, starting address, and the memory available after that.
I see.
Like
I
how
see.
much,
So,
why, yeah.
hmm.
So while allocating, they used to traverse the list of
Hmm.
available memory chunks. They
Hmm.
used to store and they used to move the same to the same information to allocated list.
I see. Makes sense. Makes sense.
If
Cool.
you go to
Um,
FreeRTOS heap implementation, that is linked list.
linked list based. Okay.
That is
Well,
linked
there
list
are
based.
also array-based memory
Yes.
allocation, like well,
Yeah.
static allocation, which are the most
Yes.
popular ones. If you're down to the absolute
Yeah.
memory constrained environment, static allocation is the way to
I
go.
think I think one of the reasons why they were used where we want like guaranteed allocation time, basically.
Yes.
When it comes to
Hmm.
linked list and other data structures, we don't know. Some allocations may happen within 1 millisecond. Some might have to travel all the way till the end, and it
Hmm.
takes like 10 or more milliseconds. So in
Right, and
cases
then
where
the
we want,
hmm.
hmm, go
So,
ahead.
Well, I was going to
so
mention the determinism takes a
Yeah,
hit
yeah,
in that
yes.
exactly.
case,
Yes,
and
yes.
for those
True.
reasons. Well,
And
actually,
majorly automotive doesn't do that to
Hmm.
avoid indirect way to avoid handling null pointer exceptions. So if there is no
okay,
dynamic memory, so
Yes.
there is no null pointer.
Yeah,
fair.
actually, there is a library also called linear allocator, so which does the same thing. Like
I
you
see.
have to give 4K and it will allocate linearly and it will keep track of the part which is allocated.
Mm-hmm.
Hmm.
Mm-hmm. Okay, I want to kind of let Dev or Totla Tiwari
Yeah.
speak because I know you wanted to add something. Go ahead.
Okay. So I think I agree with all of you guys. In particularly in embedded system, we don't use DS that extensively
Right.
because of what we are trying to do here is doing configuring the hardware, right? Writing the
Hmm.
drivers, writing the firmware, and writing the kernel of the operating system. And there, if you are thinking that okay, dynamic programming, if you are wondering if the dynamic programming is going to be used in this embedded system, then its answer is no, right?
Yeah.
It's
Or
very
very
far fetched,
rarely. Yeah.
Hmm.
very
Very
rarely. Yeah,
rarely.
yeah,
Typically, on top of an operating system, you need to have like a memory
right.
pool allocator,
Mm,
and you also need to have a problem that requires, uh,
right.
dynamic programming. Um, Definitely. Yeah.
So I think these graph, you know, uh, a lot of very complex tree implementation. These are
Hmm.
not typically used. I mean, not very extensively used in
Right.
what we do
Right.
day to day, right? Because
Hmm.
there is no scaling thing required. We don't deal with data, right?
Yeah.
We are not working with whole lot of data and then and, trying to optimize those, right? So
True.
it's like developing the firmware, writing the drivers, and there you typically write a software which configure the hardware, right?
Right.
You don't do much. Only thing that find these DSA linked list stack queues being used is in the OS primitive implementation, right?
Hmm.
Like you are handling the process, you are handling the memory management, you are handling the file management, right? There you
Mhm.
could find these things being used, but in a typical lifespan of an engineer, you don't have to rewrite those things, right?
Hmm.
You just
Fair.
use those, right?
Right.
Because the
Right.
implementation is that is the most optimized one. So you typically use those libraries, you use whatever is existing infra, and then try to develop your software. So it's
Right.
not quite extensively people are looking into, let's say they are joining with this assumptions that they are going to use DSA a lot in this domain. The answer
Hmm.
would be they would be disappointed, right? So
Or liberated,
Actually,
right,
depending on
so
which side of the DSA line you fall.
right,
I
so
want to
actually,
make some. Oh, go ahead. Go
yeah.
ahead.
So just actually, I think this statement is very generic, and I don't think this has relevance only to embedded. This has relevance to most of the software out there.
Abhay.
Yeah, yeah.
Like I know people use dictionary in Python directly. I have never seen somebody implementing dictionaries from scratch in Python or hash
right.
maps directly from Python. And similarly, there are
And that's the
lot of
sole
these
purpose of
algorithms. Yes.
libraries and high level languages, right? To not
Right.
let users worry about these details. Developers worry about
And
these details.
I mean,
so given
they're
that
the
fact,
primitives now.
Hmm.
yes. So given that fact, there are there are use cases of DSA in, and I won't say it is not used. I would say it is very application specific. For
Fair.
example, if you go to if your main job in embedded is networking, you will be doing a lot of algorithms on network. You will. I remember when we used to work on NS2,
Sorry,
we used to
could
write.
you repeat that because I think we lost your audio. Could you repeat? No,
Okay.
the
Yeah.
audio is good. Could you just repeat it? Yeah.
So I'm just saying that the use case is very application specific. So if you are in networking domain, you end up writing a lot of algorithms and data structure around it,
Mm-hmm.
around routing, around switching. And
Mm-hmm.
that's where all these trees, sliding window protocols, all these come into picture, and you implement a lot of them. If you
In
go
fact,
toward
there are
yes,
teams who deal. I mean, their sole job is to invent new novel
yeah,
data structures, right? Like for example,
yes,
compilers. They would be inventing totally different data structures and algorithms for their own use cases. So I
yes.
Right.
agree with you. I agree with Kachra said here.
So I would say even in the scope of DSA in embedded is equivalent to the scope of it has in software. The
Hmm.
and what should be emphasized is that DSA forms only small portion of it.
Hmm.
There's a lot of
Right.
code that goes around those algorithms which has nothing to do with the DSA. It's all
That
about maintenance of the system, etc., etc., etc.
that is true. I would say I kind of wanted to add a data point around the DSA or the algorithms that I have seen around me in embedded systems. Definitely, linked list and doubly linked list is something I've seen. Then stacks and queues I have seen. As Kachra said was mentioning. I have seen implementations of trees in priority queue. I have seen heap sort being implemented. That too in a tiny microcontroller, specifically in case of power management. So I would say algorithms and data structures are used in embedded system, and as you all pointed out, it's not super extensively used. The moment you are uh, trying to implement an algorithm for speed, and you have gone out of linked list, arrays, stacks, and all of those, the basic ones, uh, it's very likely that you're doing an overkill. Very likely. I suppose in embedded system, the between performance, well, between power, speed, well, again, let me just gather my thought. Between speed, memory, and performance, you pivot on memory and performance. And somewhere you got to find other ways of dealing with speed than implementing, let's say, a tree, if you can do away with a linked list. Also, the point around determinism is extremely important. How much time does an action take matters a lot more than does it happen fast enough. Does a tree traverser, is the time on that always deterministic? I think all of those things are very important. But that said, again, this is becoming like a monologue. But that said, I think DSA has its own value in the sense that it does demonstrate that somebody can think about a problem very clearly.
Hmm.
Somebody can break down complexity. I think it's a very good proxy to how someone can think. That said, should somebody go and do like 200 300 lead code problems and whatever data structure algorithm problem, I think that's an overkill. It's just overhyped. Systems level knowledge is what people seek. That is what is valued, and that's what gets you up the ladder. And well, also data structures and algorithms, if you really wanted to, you can learn it over 6 years. Why do it in 6 months or 6 weeks? Okay, that's my perspective. Go ahead.
I think to add to that, right, since you mentioned, right, that a person doesn't need to do 300 problems. And I agree with that because, not all those problems are on a different data structure, right? There would be
Right.
a whole lot of problems related to graph, a whole lot of problems related to dynamic programming, a lot of problems related to stack queues and all, right? So,
Mhm.
the important thing is to you understand a basic, fundamental of that DSA, right? Whatever,
Right.
let's say you are working on understanding stack, right? You understand its fundamental. Now,
True.
problem one could create 1,000 problem over that, right? Using that concept, right? So I think it's important to understand the data structure and not go and do the same problem again and again. All those
No.
dynamic programming problems are you know divided into two things, right? One is the bottom up and top down, right? And you
Mhm.
don't
Mhm.
have to do 100 problems to understand that. If you really want to
Right.
understand, you know just pick up a problem, right? And then go from end to end.
Hmm.
And that is the best way to understand. You don't have to do 100 problems, just do 10 problems, but you understand them in out, right?
Hmm.
And that's the concept, right? So when Google ask you a coding problem, right? They those questions would be somewhere around these basic fundamental concept, right?
True.
It's not something some alien thing, right?
Yeah, I
So
suppose that's the key, right? People are just trying to probe and understand how you think, how you break the complexity down. Can you self navigate? And in fact, I would
right.
say, particularly in an interview, uh, those who don't get stuck anywhere, well, we get zero signals out of that. So the important signal is, how do you navigate a situation when you're stuck? Because real life problems are that way. You wouldn't know the answers end to end. And the thing is, if you get stuck and you freeze, well, freezing is all right. Not being able to recover or not making any attempt to recover, I think that's scary. Defending your solution when you're going down the wrong path, that is scary. Somebody being self critical of themselves, saying, I'm making XY choice because I see this is known and this other thing I don't know, but I'm predicting X might happen. Yeah, those are the kind of people, at least personally, I like, because
Right.
it's like, hey, you are kind of having an awareness of what you might not know, which is a better
Right.
situation than getting something incorrect and then being confident about that. Yeah.
So
Uh,
I guess
Go ahead.
I will I will just add, there is a, I think all I can summarize is there is a difference between understanding data structure and cramming data.
Right. Right.
So, and I feel that everybody should read data structures because that just helps you, differentiate them. Why you should choose one data structure on another. For example, if you have done during your whole life only linked list, you will never be able to think why should I use tree in this situation. Maybe tree is a
Right.
better algorithm for that. So
Right.
yes, there is a value. You should go and learn all these data structures, but there is a difference between understanding the core concepts of structures and cramming some 500 problems of lead code and
Yeah.
solving based on patterns. You should not solve based on patterns. You should
Patterns. Right.
solve based on your understanding
Right.
and
Mhm.
your gut feeling where you want this problem to take over.
Right. I
Yeah.
suppose this is the difference, right? A lot of people solve the problem, but are still not called over or, offered. And then they are like, hey, what went wrong? I did solve the problem. It's like, yeah, good, you solved the problem, but there were 10,000 other, well, 10,000 is too much, 10 other indicators that, the interviewer was looking for. And all of those were a miss, complete miss, right?
Right.
So it's not just how well and how quickly you can solve the problem. That's part of the credibility, but not all of it. Yeah. I think, Wasim or Munna here was saying
Yeah.
something. Go ahead. Go ahead.
Yeah, I was so I just want to share my experience. Like data structures help me to think in a structured way and
Right.
break down the complex problem into tiny pieces. So, but doing extensively will not help you much after certain period of time. Like when
Right.
I was first introduced with graph, my thinking perspective of certain problem has completely changed, which I used to think in a linear way.
Mm-hmm.
So it is good to understand or to know the different way to solve the problem or other
Right.
uh, way to see the things. But if I see it is with the respect of embedded system,
Mm.
it is used at very niche areas,
Right. And very rarely.
like at the time of memory management or network
Mm.
packet uh, processing.
Right. Resource
Like
management.
particular cues are used when we read from the sensors
Hmm.
or when we interact with the high speed devices.
Right. Right.
And when we deal
So
with the low speed devices, we directly go for the linked list or the buffer.
Right. So let me maybe summarize the discussion so far like this, that, knowing data structures and algorithms help. It's not everything. You can learn them over time. And the preferred ones are the simple data structures and algorithms like the linked list traversal, doubly linked list, stacks, queues, the simple ones, the friendly ones. Um, Trees and graphs are used very rarely in niche, applications or use cases. Um, so that said, what I want to do is, for today, we were planning to limit our podcast to kind of 30 minutes ish. We're about at that point. Why don't we do this? Why don't we go around the table and talk about our interview experiences, so that next time we can elaborate a lot more on our interview experiences? But can you give just a brief summary as to, were there data structures algorithms involved in your interviews? How much of it? How much did it help? How much did it not help? So on and so forth. Go ahead. Maybe we'll start
Can I
with
go
Rajat
ahead?
and then, okay, go ahead. Go ahead, Wasim. Go ahead.
Okay, so when I started my journey, like back then in 2015, the data structures were seldom asked. Like most of the C and C++ features and OOPS concept used to be asked. And at the end of the session of interview, they used to ask us to implement or reverse the linked list, implement the linked list or reverse the linked list, or find if there is a loop in the linked list.
Right.
So these were the standard questions back then in 2015. But
Mhm.
when I applied for a more embedded, means more towards, as I have tilted more towards the embedded profile, I have been asked about mutex logs, more towards the software side of embedded system, like
Right.
spin lock, mutex lock, how these things work, semaphore, uh, interprocess communication, IPCs. And there also, if we can say about, if we can explain like how we can traverse the linked list, and if you know linked list and binary search tree, it is okay to go. But what I have seen, that scenario has changed in 2019. After that, people in the interview started asking questions on graph and dynamic programming more. So
But
I
this
took a
is
step back
general
and I,
software.
yeah. So earlier there was no pre screening round in most of the companies. So now
Yes.
what happened, like if you apply for any big company, there will be two pre-screening round or one pre-screening round, which will be
Mhm.
based on algorithms. And they
I see.
mainly ask
Okay.
graph questions and binary search questions.
You're
In the
saying,
third and fourth round, they will go to the embedded side or your profile
I see.
uh,
I see.
things. So to
Domain
get,
specific.
you should learn embedded system, but get in, it is required that you should prepare for the competitive programming or
Mhm.
DSA. But
Okay.
um especially when you apply in some good companies, I remember
I
I have a opportunity to take an interview for one small company, and they did not ask me to go for these algorithm and DSA problems. They were interested on a people who are good at C++, and the guys should know that C++ 11 onwards feature, and they should
Mhm.
able to break down the problem and code it in given time.
I see. Okay. That's pretty cool. A mix of both then, domain specific and also DSA. Cool. Who wants to go next?
Piyush, can I suggest one thing? I think with the interest of time, what I feel is let's do, each person in each podcast, and we will
Yeah.
share,
Yes.
our interview experience in detail,
Right.
but not
Right.
all at once, I guess, because that
But
Yeah.
I
might.
kind of wanted to roll off and end at just whether or not you were asked DSA. That's all. I think that's
Hmm.
what I was seeking particularly.
Okay.
So
Yes,
maybe you
I
can just
was.
summarize you.
Yes.
Oh, okay. To what degree?
Well, I was asked dynamic programming, trees, and I think one or two questions around embedded. But that
Okay.
was, I think, with this answer, I'm not doing enough justice. This was back in
Well,
time
that's why
where
we would
things
have
were
like the
different.
next. Yeah,
Yes,
we'll
yes,
have like a
exactly.
next podcast specifically
True.
on that. Okay, Rajat,
So,
do you
I
want
mean,
to go next?
people are gonna call
Okay.
us, I mean, we are preaching don't do don't do DSA, and then we crack
No.
interviews with the DSA. But I think that time was different. Now, I think almost everyone has started to realize, okay, what degree, DSA is useful and embedded, and people have actually started to change their
Okay.
judging criteria. So yeah, more on that I think in next
Yeah.
podcast.
Okay. Maybe the three of us now. Rajat, do you want to go next?
Okay. So I would say in my whole career, I have never written anything above linked list even in interviews.
That
So
is a very
when
encouraging answer. Perfect.
when I was preparing for Google, everybody told me that I should do lead code, go on lead code, look at the problems, solve those problems. I did go for lead code. I won't lie. I solved arrays problem, stack problem, queues problem, linked list problem. I knew them. I solved them. But the moment I started solving a tree problem, I coded the first tree problem, and I'm like, for 8 years or in my career, I have never done this. I
Right.
don't see a point of doing this. And if linked list cannot get me into Google, into this job profile, maybe this job profile doesn't suit me. And I just left lead code right over there and didn't do any problems out there. That's it. Do I not know what tree, etc.? I know their basic concepts. If given enough 2 days, I can even code a tree. But
Right.
if
Right.
somebody asks me, you have half an hour, please code this tree problem. Sorry, you got the wrong candidate. Maybe you should schedule the interview the next month.
Perfect.
So
I think
honestly said, never did DSA above linked list, and even till now, I have not done it.
you're doing fine in life. Okay, cool,
I'm doing
cool,
fine in life without
cool.
Without trees.
without trees. I like trees,
So
but
man,
in my garden.
Yeah, yeah.
yeah. Yeah.
Go ahead, Dave.
Yeah, so I think we were hired for general SWE role. When you're out of college, you haven't had done a lot of projects, right? The only
Yeah.
thing left to you is to ask aptitude questions, programming
Academia, really. Yeah.
language questions, academic questions, or you are left with DSA problems, right?
Right.
You cannot ask industry oriented questions, right? Because they don't have that experience.
You
So
cannot expect a very
right,
polished answer, actually.
right,
Yeah.
yeah,
I actually differ with that.
Sure, but that's for another podcast.
Yeah, that's for another podcast. This is only focus
Yeah.
on DSA is a very FANG thing. Not much
right.
company in much of the industry does that. It's popularized by FANG.
Well,
Yeah,
to
I
our
think
view,
the next podcast is going to go crazy, I guess.
I think so. Yeah.
Yeah.
But well, for
So
this actually, we wanted to experiment and wind up within like 40 minutes. We are 3 minutes short of it. So go ahead,
So,
Dave. You
yeah.
conclude and then.
yeah. So I was asked, all the round I was asked coding DSA problems. Yeah, I never seen uh, you know embedded oriented questions because I was hired for SWE role, general embedded,
Right. Fair.
general software engineer.
Fair. So maybe then I'll take over, and I have been through both DSA, Algo, and well, first off, I interviewed in a lot of places, 13, 14 places, all hardware companies, semiconductor companies. Two or three of them focused on DSA algorithms a little bit, in the sense just as a way of filtration, whether or not I could think.
Hmm.
And once I was through those rounds, it was specific to embedded and on the side of electronics a little bit. I would say I have majorly used stacks, queues, linked lists. I had proposed solving a problem using a tree, but then in interest of time, I said, "Hey, can I do this using a linked list?" And the interviewer just agreed, and I ended up doing that way. So I think what helped me back then was the fact that I demonstrated I know how those concepts, or I know of those concepts and those data structures. But in interest of time, I would go and implement the simpler ones. That's what helped me. I much like Rajat, I would say maybe 10% of my interviews had that. And would I get a job if I had not known them? Well, first 5 years of my career were without DSA. Again, when I was preparing for Google, I implemented the N Queens problem. I tried to do that dynamic programming, and the only reason I did that was I was not sure how Google interviews for embedded systems. Turns out they asked me embedded questions with a little bit of twist that required a little bit of DSA. Yeah, that's about it. Now, I think what we can do is, in the interest of time, to keep this is an experimental podcast within 40 minutes. Ideally, we'll want to do it within 30 minutes. And the audience can, the viewers can let us know whether or not this time is good. What is the preferred time? And yeah, I think that was DSA and algorithms in embedded systems, the discussion for today. And next
And
time,
we
maybe
will
we can
continue,
take up.
definitely.
Yeah, we
This is a
should
hot
Yeah.
continue.
topic.
Watch out for next podcast. It would be DSA versus development, I guess.
This
Sure.
war is
Okay,
not over.
Yeah,
it's just
it's
started.
more-
Okay.
yeah.
Fair. Okay, then maybe we are exactly 30 seconds over. Let's call it a podcast for today, and let's meet up next time. Yeah.
Yeah.
Cool.
All right.
Bye bye.
Bye bye,
All
everyone.
right. Bye bye.